Hello everybody, I'm Simon Coter and I'm Director of Product Management for Oracle VM and VirtualBox. Thank you for joining us and the time you're going to dedicate to this webcast. Today I'm going to be talking about Oracle VM VirtualBox, Vagrant and how these very cool utilities can help you to build a DevOps solution. This is our safe harbor statement to remind that this webinar registration is intended only to outline our general product direction, and it's not a commitment to deliver any material or code. Development, release, and timing of any feature described remains at sole discretion of Oracle. Here's the agenda I'm going to discuss with you today. In the first section, I'll introduce the concept of DevOps and why it's time to evaluate and work on it. Then I'll move to the products on which you can rely, so Oracle VM VirtualBox and Vagrant, and how, thanks to these utilities, you can create your own virtualization DevOps environment. We will also have a little demo running on a laptop, and at the end I'll leave you a set of documentation references of both VirtualBox and Vagrant. At the end of this video, you will also have the time to get the answers you need on what I'm going to present. So, first question, what is DevOps? So, DevOps target is to solve this very common issue between development and operation business units. As you can see on the left, we have an admin saying, hey, it's not my machines, it's your code. While on the right we have a developer replying, it's not my code, it's your machines. DevOps is a combination of software development and operations, and as its name suggests, it's a melding of these two disciplines in order to emphasize communication, collaboration, and cohesion between the traditionally separate developer and IT operations teams. Rather than seeing this as two distinct groups who are responsible for their specific task but don't really work together, the DevOps methodology recognizes the interdependence of these two groups. By integrating this function as one team or department, DevOps helps an organization deploy software more frequently while maintaining service stability and gaining the speed necessary for more innovation. And in the end, everyone is able to deliver the best results and overall experience possible to the customer. So, DevOps, development and operations, is a term used to refer to a set of practices that emphasize the collaboration and communication of both software developers and information technology professionals while automating the process of software delivery and infrastructure changes. It aims at establishing a culture and environment where building, testing, and releasing software can happen rapidly, frequently, and more reliably. Here we have a picture that shows one of the main problems that DevOps could fix. More than one time, once the code correctly worked on dev, it's not more a developer problem what happens next. DevOps, thanks to its automation processes, allows to create real continuative collaboration between developers and IT professionals that, based on automated processes, will really do the difference. On this picture, you can see development group on the left and operations one on the right. While on the left you can see a very high interest on introducing new features and enhancement, also to enable the business. On the right you have operation group that do not want to introduce regressions, want to respect service level agreement, uptime and security. While on the left you have one team asking to work on new technology quickly, on the right you have a group that is much more conservative and do not want to change anything that actually works. So, how to deal with this? A bit of history. If we go back 20 years prior to .com, there were software companies like Oracle, Adobe, Microsoft, SAP, and so on. While moving into the dot-com era, we see the rise of companies whose core competency is actually software that their actual revenue streams come from elsewhere. If we fast forward to 2014 or 2015, we see massive disruption from startups companies where core competency is software being used to disrupt the traditional approach. While these companies enjoy a strong position in the market, they had to retain tremendous software agility. And these startups are not only competing with established businesses, but also face other disruptive startups. DevOps has really been driven by this type of company to give them fast moving agility to innovate in software, to respond to market changes or competitive threats. So now we see enterprises looking at DevOps both as a path to take market share from traditional rivals, but also as a defensive shield to protect them not only from those rivals, but also the traditionally faster moving smaller competitors and disruptive startups. And this is also why DevOps is mostly culture. Automation. But what are we automating? Infrastructure as code, continuous integration, or continuous deployment as the next step of continuous integration, continuous testing and monitoring. All these automations obviously will require an initial investment in terms of money and time, but once ready, will allow you to deliver your solution in minutes or hours instead of days or weeks. So it's important to know that DevOps requires some really big changes across the organization. Changes that impact culture, process, and people. DevOps isn't easy, and every company's journey is different, but the payoff is really tremendous. DevOps will help you to deploy code faster and more often, spot and fix errors sooner, and ultimately meet market demands and customer expectations better. Second point on the first section of our agenda. Why is now the time for DevOps? So why is now time for all this automation? So business value is driving DevOps. Traditional IT organization common problems are mostly due to poor communication and coordination between team leads that impact the app release cycles with delays. Manual intervention leads to human errors and non-repeatable processes. Huge amount of waste exists because of differently configured environments, development, QA, stage, production. And usually you can also see multiple processes with a no standard defined, siloed teams, so development, operation, IT, QA, QE, and so on, and non-integrated tools and fragmented data. So how can you avoid this problem and why DevOps could help you on this today? You can increase the automation. You can automate everything. You can accelerate routine tasks and ensure repeatability and reduce errors. You can reduce the latency with a continuous workflow for integration, testing, builds, API, virtualization, delivery, and deployment. So all targets of the DevOps approach. You can increase visibility with a continuous assessment, monitoring, and measure everything. Custom feedback loops, prioritize business and dev planning, provide visibility across teams, and enable collaboration and include planning and security for your application. Results with a good DevOps approach could be a faster time to market because you can increase the frequency and accuracy of releases. The automation processes will give much more time to the people. Cost. You will be able to reduce OPEX by automating processes. This will also prevent human errors and reduce downtime. And with a focus on business, because you will allow employees to focus on high value activities that will also improve employees' professional satisfaction. And one important thing to know is that the good and also open technology is already available. As you can see, the automation tools had been started in 2005 and more arrived in the following years. Between them, we can also see Vagrant, one of the DevOps technology that we are going to discuss today. On the right, a very cool picture that really shows what the automation can do compared to what it would require with manual steps. It's also important to know that you won't get a complete DevOps solution by one single product. More than one is usually needed. Here we have configuration management products like Ansible, Puppet, Chef, or continuous integration and delivery products like Jenkins or Rundeck, versioning control products like Git or Subversion, virtualization products like Docker or Vagrant, testing products like Gradle or Robot, and binary management products like Nexus or Artifactory. Each product gives you automation for a specific section of group of operations, and what we are going to discuss today is something related to the virtualization section with Vagrant and VirtualBox as the base hypervisor. Maybe someone has never worked with VirtualBox, and so I'm also going to give you a brief overview of this product. Here you can see the Oracle virtualization portfolio, where we have solutions for desktops as VirtualBox and Secure Global Desktop, on-premise solutions like Oracle VM Server for x86 and Spark, and the Oracle Public Cloud. Let me introduce VirtualBox. This is a desktop virtualization product and it's part of Oracle virtualization portfolio. VirtualBox lets you create virtual machines that run on your laptop, on your personal computer, or on your Macintosh. So if your desktop computer or laptop is running Windows, macOS, or Linux or Solaris, you can create virtual machines running any of those operating systems. And this is very useful for test development, for running the occasional use of some product that doesn't exist on your normal desktop or environment. It's fast and it's powerful. We will talk about some of the capabilities of the product as we go through this. And for personal use, this is a free download that anybody can make use of. So, why do people use this? Well, the first thing is that it's a cross-platform solution. What does it mean cross-platform? It means that the same product with the same features is available for all the main x86 platforms. And moreover, you can have the same x86 platforms running as virtual machines on top of VirtualBox. VirtualBox is very helpful for bring your own device situation where there may be a standard software application that is needed within a company, but all the participants using that, they bring their own computers with them of a variety of different types. And they can then still use the same standard application that may be shipped in one particular platform. It could be used for desktop virtualization and migration. It could be used for running old operating systems that are not longer supported on today's current personal computers. And obviously, it can also be used as a way to deliver software products for a client base or for a demo, for example. This operating system with this patch level, different operating system, different hardware types, this can require a lot of hardware to create all the possible combination of operating system and patch level, JVM versions, compiler version, and so forth. Or if we have customer bases that are on a different operating system, we might have to develop for each of these different types of combination. Well, that's one use case. We might like to have sandboxes for experimentation, where to set up an environment and do something that might be destructive. Or you would like to have in a private environment that you could throw away if it's not good, or you can keep if you like it. So with VirtualBox you can run all x86 operating systems on your own laptop or desktop environment. You can quickly and easily test new platforms, you can create multi-layer test and development environment, or you can also run legacy platforms or applications on modern hardware. And last but not least, you can also use VirtualBox to create and develop your applications and solutions that, once ready, can be exported to a cloud provider like Oracle. So, VirtualBox is one unique product within Oracle. Foundations on which is based are, at the same time, a vibrant community participation. We have so many users that collaborate and report feedbacks for VirtualBox, and also the enterprise Oracle development and support that constantly work to supply the best enterprise service level possible. And for sure, if you are interested, you can find further and detailed information related to VirtualBox also by Googling it. That said, I'm now going to give you a brief overview of the other piece of software to build this DevOps environment, Vagrant. So, what is Vagrant? Vagrant is a tool to build development environments based on virtual machines. It's focused to create environments that are very similar to production VMs or servers. It uses hypervisors, Docker, or cloud as providers, and it's written in Ruby code. And like VirtualBox, Vagrant is available for all x86 platforms, so Linux, Windows, and also macOS X. Vagrant provides the same easy workflow regardless of your role as a developer, operator, or designer. It leverages a declarative configuration file which describes all your software requirements, packages, operating system configuration, users, and more. Vagrant aims to mirror production environment by providing the same operating system, packages, users, and configurations, all while giving users the flexibility to use their preferred editor, integrated development environment, and browser. Vagrant also integrates with your existing configuration management tooling like Chef, Puppet, Ansible, or Salt, so you can use the same scripts to configure Vagrant as production. Vagrant works on Mac, Linux, and Windows, and more. Remote development environments force users to give up their favorite editors and programs, while with the VirtualBox integration, you can also work on your own laptop. Vagrant can work on hypervisors like VirtualBox, Docker, or also on different cloud vendors. And why Vagrant? Vagrant provides easy to configure, reproducible, and portable work environments built on top of industry standard technology and controlled by a single consistent workflow to help maximize the productivity and flexibility of you and your team. So, thanks to Vagrant, you can easily build reproducible environments with an automated workflow. No human intervention is needed, and everyone, like an IT administrator or a developer, can easily build the same environment with a simple command. So, how can I start to play with Vagrant and VirtualBox? I'm now going to share with you some concepts and at the same time some very common commands that will help you to approach DevOps based on Vagrant and VirtualBox. First point, the installation. Obviously, the first step requires to install VirtualBox and Vagrant on your own machine. For each product, you can find the executable that will proceed to the software installation. You'll find .exe files for Windows, RPMs or source code for Linux, and DMG images for macOS X. Once the software has been installed, you'll need a Vagrant box. What is a Vagrant box? It's a previously built Vagrant virtual machine image, pre-configured and ready to run. It's a very similar solution to the Oracle VM templates that we have for our Oracle on-premise open cloud infrastructure. The boxes can cover all x86 platforms like Windows, Linux, BSD, and also macOS X. And you can also create your own boxes, obviously. And how can I get a Vagrant box? There is more than one public catalog. Between them, we can mention the official catalog from HashiCorp, the company that actually owns the Vagrant project, or also the Oracle Linux Vagrant boxes catalog, available on our YAM website. By Vagrant, you can manage catalogs for your own installation and, if needed, configure more than one catalog. You also have the option to create your own catalog, or if you prefer, get a Vagrant box by specifying the URL where it resides. So below you can see a picture where you can see the syntax of the command vagrant box add, the name of the box available, URL where to download the box, and the provider. The provider in our case is VirtualBox. Now, how can I create a Vagrant environment? First of all, the project concept. A Vagrant project is an host operating system folder that will guest your box images. You can have more than one project, and each of them can be managed with a single configuration file, the Vagrant file. The main function of the Vagrant file is to describe the virtual machines required for a project, as well as how to configure and provision these machines. The idea is that when a developer checks out some code from version control, which has a Vagrant file, that developer can simply Vagrant app to get a fully provisioned virtual environment to develop that product. As you can see from the example picture, by the command vagrant init, the default configuration file, the default Vagrant file, has been created. Vagrant is meant to run with one Vagrant file per project, and the Vagrant file is supposed to be committed to version control. This allows other developers involved in the project to check out the code, run Vagrant app, and be on their way. Vagrant files are portable across every platform Vagrant supports. The syntax of Vagrant file is Ruby, but knowledge of the Ruby programming language is not necessary to make modification to the Vagrant file, since it is mostly simple variable assignment. In fact, Ruby is not even the most popular community Vagrant is used within. We should help show you that despite not having Ruby knowledge, people are very successful with Vagrant. So, how can I start to use Vagrant? On these pictures, you can see different types of Vagrant operations. The first one on the left, for example, shows you a tentative startup, so the command is vagrant app, of a box named Coter-box. Obviously, this box image does not exist locally and moreover does not exist on the default HashiCorp box catalog. So the error is clear here. Could not open a box named Coter-box. While moving on the second picture, always on the left, we can see how to download a real box image from a specific URL. Here we have one Vagrant box image containing an Oracle Linux 7.3 image. Moving on the right, first picture above, here you can see the content of a Vagrant box image. A box image is composed of the virtual disk containing the operating system or your own application installed, a Vagrant file dedicated to the box image, and one OVF descriptor file, so the open virtualization format that is the standard for the hypervisors, and at the end a JSON metadata file containing configuration options for Vagrant, like for example the provider that in our case is VirtualBox. Once the box has been downloaded and is in place, we can start out the Vagrant machine by executing the command vagrant app. Now, how can I connect and work on my Vagrant machine? On the picture on the left, as you can see, we have the machine creation obtained by the command vagrant app. Reading the output of the command, we can see that first point, the machine will have a forwarded port, so the port number 22 of the machine will be forwarded to the port number 2222 of the host operating system to give SSH access. The access will be granted to the user Vagrant by using a private SSH key from the host operating system to the guest machine, and there will be a shared folder between the host operating system and the guest machine that will be automatically mounted by the machine itself. On the right, you can see how to get access to the machine, so by Vagrant SSH without any password prompt. You can see the shared folder already mounted by the Vagrant machine, and also the ability to get administrator rights on the machine by executing sudo. Here you can see other very useful Vagrant commands to remember. So Vagrant halt, the command to shut down the Vagrant machine running. Vagrant reload, that is the command to restart the running machine or to pick up an updated version of the Vagrant file. And Vagrant destroy, to shut down and destroy the Vagrant machine running. With this option, the box image downloaded will be obviously preserved. Is it possible to customize boxes? Obviously, yes. You can do it by editing the Vagrant file, so the unique configuration file for your Vagrant project. Over there, you can customize more things, such as the port forwarding configuration or the resources that will be dedicated to the machine. For example, suppose that I want to restart my machine with more memory or CPUs. The steps to accomplish this operation are: first, I need to edit the Vagrant file and apply the changes needed, and the second, restart the machine by executing Vagrant reload. If you are interested to customize more your machines, you can also evaluate all the options available into the underlying hypervisor, so VirtualBox, by executing the command vboxmanage on your host operating system. Now, coming back on the Vagrant box concept. A Vagrant box is a tar gzipped file containing the Vagrant file, so the information from this file will be merged into your Vagrant file that is created when you run Vagrant init into a project. Then you have VMDK files that are the virtual disks containing the machine image with operating system or applications. Then we have the OVF configuration file that defines the virtual hardware for the box based on the Open Virtualization format. And then we have the metadata JSON file that contains Vagrant metadata information, like, for example, which provider the box works with. So here we are. I'm now going to show you a brief demo on how you can start to play with Vagrant and VirtualBox and Oracle Linux on your own laptop or desktop environment. So, obviously, the main command to use is Vagrant. By executing it, you can also see the help of the command. And here we have a huge list of common commands, like box to manage our boxes, connect, destroy, reload, halt, package, PowerShell and RDP for Windows boxes, status, version, and so on. As you can see, for each command you can also find a description of the same. Additional subcommands are also available, but are either more advanced or not commonly used. And if you want to get all the options for a specific command, you can also execute Vagrant command -h. For example, we can try now to see which are the options or the subcommands available for Vagrant box. So, yeah, what I have to do is to execute Vagrant box -h, and here we have options for this command like add, list, or other like repackage or update. Another thing, for example, now I can check the list of boxes already available by executing Vagrant box list, or I can check the Vagrant release installed on my machine. Now, let me show you where you can find Vagrant boxes for Oracle Linux. For all our images, we have a standard defined that obviously can be customized on your own environment. By a web connection to yum.oracle.com/boxes, you can find our official Vagrant boxes for Oracle Linux. Between them, we can see images for Oracle Linux 6 and also the latest Oracle Linux 7.3. For each box, you can also find the URL that you need to download the Vagrant box on your own laptop or desktop environment, and also the checksum of these images. Last but not least, you can also see the example commands on how to start using Oracle Linux Vagrant boxes. Below, one example on how to verify the checksum of the downloaded box. I'm going now to create my own Vagrant project. To create a Vagrant project, the only thing that I need is a directory. Once my project is ready, first step I'm going to execute is the download on one box from yum.oracle.com, and this is an Oracle Linux 7 update free. Obviously, the download of an image is needed only the first time. Following machines will start from the same image. Once my Oracle Linux box has been downloaded, next step is to create the Vagrant file for my project. By executing the command vagrant init ol7u3, the box imported, a default Vagrant file will be automatically created. Into the Vagrant file for this project, you can see different configuration options like network configuration, CPUs, and memory allocated. For all the details, you can refer to the Vagrant documentation. So coming back to our project, next step is to start the Vagrant box imported. To accomplish this step, I only need to execute Vagrant app. By this command, the default box image, in this case ol7u3, will be started up. As you can see, this machine has started with a forwarded port for SSH access, so the port number 22 on the machine will be redirected to port 2222 on the host system. Another automatic configuration is related to the shared folders. In fact, we have the directory on the host system that is mounted under the file system/vagrant on the machine. So here we have the port dedicated to the SSH access, here the shared folder. So now I only need to connect to the running machine. To accomplish this, the command is so easy, vagrant SSH, and automatically I'm connected to the Oracle Linux 7 machine. The authentication obviously happens by the SSH key available on my host system. And this is a common virtual machine where I can execute all the commands like hostname, or verify the Oracle Linux release installed, or verify the running kernel. I'm connected with the user Vagrant, but obviously I have total administration of my machine. By sudo, I can get administrative privileges. You can also check the /vagrant mount point, the default share, where you have read-write privileges and where you can share files and directories between the host and the guest operating system. Another important evaluation, the actual Vagrant box running, it's really a simple VirtualBox machine, and you can check the process running on your host operating system. So here you can check the process running, and you will see that we have a process, a VirtualBox process, with the machine running. Now, on the same Vagrant project, we can also add further boxes or machines. For example, I can add an Oracle Linux 6 machine by downloading another box from yum.oracle.com. And this is an Oracle Linux 6 Update 9 box. Once the download is complete, if I try to start or initialize the second machine, the Oracle Linux 6, I won't be able to do it using the same commands used before. As you can see, you will get an error saying that Vagrant file already exists in this directory. And the same if I'm going to use Vagrant app, because actually the configuration file has only one VM defined. To start more than one machine into a project, I need to properly configure my machines. So, first of all, on our demo, I have to stop the running machine running as the default one. Once stopped, obviously, also the VirtualBox process won't exist anymore. To properly configure more machine, I have to edit the Vagrant file of my project. As usual, the best practice suggests to backup Vagrant file before editing it. So, into the Vagrant file, the configuration file of my project, I'm now going to comment out the original machine name and create two different ones. Because I'll have two different Vagrant machines, 6 and 7, where each one will rely on a specific box, 6 on OL6U9 and 7 on OL7U3. Now, I can start two different machines of my project. To start the machine named 6, I'll have to execute Vagrant app 6. As seen before, the redirected SSH port will be 2222, and as you can see, the box used is OL6U9. On the left column, you can see that we do not have anymore default, but we have 6, so the name that we used into the Vagrant file. Once the 6 machine has been started, I can proceed to start the machine named 7. As you can see, Vagrant detected the port collision because also the machine named 7 is trying to get port 2222 for SSH access. Automatically, Vagrant will choose a different port to redirect the SSH access. And here, in this example, the port will be 2200. Now, to connect to my machines, Vagrant SSH won't be enough. We need to specify the machine name we want to connect to. So to connect to the machine named 6, I'll execute the Vagrant SSH6, and then I can also check the Oracle Linux release. While to connect to the machine named 7, I'll execute the Vagrant SSH7. While working on a Vagrant project with more machines, an important point to consider is that I have a distributed shared folder between all the machines. So a file created from one machine can also be read or updated by another machine, part of the same Vagrant project. As you can see here, I created a file into the machine, and now I'm going to connect to the other machine, and also on the other machine I have the access in read-write mode to the same text file. We saw Oracle Linux box images, but by switching to the HashiCorp Vagrant catalog, we can also find a very huge list of ready-to-use boxes. As you can see here, you have a real search engine for Vagrant boxes. You can look for providers or sort the list by number of downloads or creation update date. You can look for boxes with Oracle products, or you can look for Windows boxes, for example. And here we have a Microsoft Windows 10 box. So now, how can I add one box from HashiCorp catalog? First of all, I have to edit my Vagrant file to add a new box to the project. I'll give the name Ubuntu to this box, coming from HashiCorp catalog, and as I already did for Oracle Linux boxes, I need to add an entry for this machine. So I'm going to add Ubuntu, and the name Ubuntu will refer to the specific VM, and so the name that I got from the HashiCorp website. Okay. So now the command to start the Ubuntu box, as you already know, is vagrant app Ubuntu. The important thing here is that we didn't specify the URL because the HashiCorp catalog is the default one, and so we do not need to specify the URL. As already happened before, while we are going to start this Vagrant machine, Vagrant detected a port collision and so evaluated a new port for the SSH access to this Ubuntu machine. So, like for the Oracle Linux machines, also for the Ubuntu one, we have the port dedicated to the Vagrant SSH access and the shared folder mounted. Now, so the machine now is going to start and the process is now completed. So while verifying the VirtualBox process is running, you will see that we have 3 different processes, one for each VM, for each image, running on the host operating system. Obviously, to connect to the Ubuntu machine, I'll have to execute Vagrant SSH Ubuntu. And here, our running Ubuntu machine. And what about the network? With Vagrant and VirtualBox, I have the option to define private network managed by DHCP or a static IP address, but at the same time, I also have the option to define public networks managed by DHCP. I can enable default routing and also static IP addresses. Coming back to our environment, how can I define a private network? The first step could be to define a common user on my machines. This user could be used for the connection between the machines themselves, or maybe also for a particular connection from the host operating system to the machine. So I'm now going to define the user Oracle here on the Oracle Linux 6 machine and also on the Oracle Linux 7 machine. Obviously, I also need to define a password for the Linux user. Okay. So, and for the private network, what I have to do, as most of you already understood, I'll have to edit my Vagrant file. I'll take a backup of the existing configuration and then I will add a line for the private network to the configuration file. So here I define a private network based on DHCP. To enable this network on my machines, I need to reload them. The command to reload the machine is vagrant reload machine name, in this case Ubuntu. As you can see, while restarting, the machine is now going to pick up a second virtual NIC and not only one. So we have 2 different virtual NICs here, one for the network and the other one for the host-only network. By connecting to the machine, and by vagrant SSH command, I can check which is the IP address assigned by the DHCP server. and here we have the IP address associated. I can also check that this IP address is reachable by my host operating system, and by that virtual NIC I can also connect to the machine using standard SSH. And the same thing obviously is also valid for other machines like 6 and 7. So I'm now going to reload also the other two Oracle Linux machines. First the Oracle Linux 6 and then also the Oracle Linux 7. And the target of this reload is only to pick up the second card based on host-only network. Now the latest machine, so Oracle Linux 7, so Vagrant reload 7. And also the third machine will pick up the second virtual NIC. Once all the machines have been reloaded, you can collect their IP addresses on the same private subnet. On the Ubuntu machine we had the IP ending with 5, on the Oracle Linux 6 we have the IP address ending with 6, and so we can check Vagrant SSH 6, and here the IP address of this machine on the host-only network, and then on the Oracle Linux 7 machine we have the IP address ending with 7. It's important to know that direct SSH access between VMs or also the SSH access from the host operating system could be accepted only by SSH keys. This is usually valid for all the latest releases of Vagrant box images. In fact, I cannot connect from the 7 machine to the 6 one by supplying the Oracle user password. And here you have the example. But obviously, you can always set up the SSH keys for your own users. And here, some example where you can see that SSH access is not allowed without SSH keys on Oracle Linux 6 and 7 box images. Obviously, this is a limit valid and in place only for SSH access, and you can also change this kind of configuration. IP address enabled as host-only virtual NIC will be always reachable from the machine and from the host operating system. And so if you are going, for example, to build up a web server listening on a port that could be the 81 or could be the 443 for HTTPS protocol, these services for sure will work correctly. And here you can see, so from the host operating system, I have been able to ping all the IP addresses, and the same thing is also valid while pinging VMs from other machines. I'm now going to stop the entire environment. The command to stop my machine is Vagrant halt. Even if I always try to use shutdown, I'm used to use shutdown within the Linux VMs. I'm now going to share with you some references for both products, Vagrant and VirtualBox. In the meantime, I would like to thank you for the time dedicated to this webcast, and please feel free to ask your questions now. I'll be glad to answer and also give you further details if needed. Thank you again.